The objective here is to have fun. Well, I'm going to try as we get through these long lists of assembly instructions. Today we'll be focusing on binary and decimal arithmetic, and to get warmed up, let's go ahead and name 5 data transfer instructions you remember from the last video. We ended by looking at an example of some assembly here, so move EAX was a good example of a data transfer instruction. And what you're doing is you're holding the EAX register in your hand like a coffee cup and pouring nothing into it. Well, it'll be all zeros all the way across. And if we're talking about EAX, we're talking about 32 zeros. Alright, so let's get rolling here. So the binary arithmetic instructions perform basic binary integer computations on byte, word, and double word integers located in either memory or the registers. So key word right there is integer, after we just spent several videos talking about floating point. Oh, and right before we begin here, I showed you a good exercise to do if you're bored or you're looking to just like begin this whole process of learning assembly. I don't know if I could recommend this as a good use of your time, but at least it doesn't take too much mental stamina. But what you could do is look at these words, read the definitions, and put them in a code editor like mine here. And if you're really good on first glance, you should be able to explain what that mnemonic is trying to say. So for example, conditional move if not less. So you use that instruction and then you put 2 operands next to it, right? Coffee cup and pot. And if the coffee cup is not less than the pot, then it's going to conditionally move to a certain area of your program. But again, those are conditional data movements. Let's focus on arithmetic. ADCX is an unsigned integer add with carry. You get 2 integers, they're not signed, so they're positive numbers. You add those 2, and if you need a carry, you carry. Next we have ADOX. This is an unsigned integer add with overflow. We got just a regular add, that is so easy. Then ADC, add with carry. Subtract with borrow. Signed multiply is IMUL. IMUL. Why the I? Because it starts with the word signed. Why did they put the I in the beginning of MUL? I do not know. But if you want to multiply 2 numbers that are for sure positive, you would just do a regular MUL. At least they're consistent, so IDIV and DIV. IDiv. Increment is a part of the arithmetic. I mean, I guess that makes sense, because if you increment, you add 1. So adding arithmetic. Decrement. So I kind of wonder why they don't just keep the add and subtract only here, but if it's easy to wire up at the processor level, I guess they did it. Ooh, or maybe at the lowest level, these are the same. No, they couldn't be. I just want to see the microscopic wiring that is done. Sorry if I confused you. Well, the next arithmetic instruction is the negation. Neg for negate. And then if you need to, you could just compare 2 numbers. So the question is, which binary instruction stood out to you? If we jump over to our random assembly example, I could see a compare right there, right away. So there's an example of binary arithmetic. Section 513 is the decimal arithmetic instructions. These instructions perform decimal arithmetic on binary coded decimal data. Oh, so the only difference between decimal and binary is that decimal is, these instructions are specifically working on BCDs. So good question, what's the difference between binary and decimal arithmetic? And if you remember, BCDs are really weird because they are basically like 2-digit numbers broken up. So a picture is worth 1,000 words. Everything in a BCD and binary is the same until you get to 9. Now that we're in the 2 digits area, we're going to have an entire byte make the number 10, which there's got to be purposes for, or why would they do that? I think it's a little silly maybe at this lower level with an example like 10. So I mean literally the lower number level. It looks so much better to just do 10 like this in binary versus this. But whatever, they know what they're doing. So those instructions are like DAA for decimal adjust after addition. Then you could decimal adjust after subtraction. And now we got a bunch of ASCII stuff. So AAA, ASCII adjust after addition. AAS, ASCII adjust after subtraction. Oh, you see a little pattern here, AAM and AAD, so there you go. Now remember, many of these instructions I put into note cards using the Tiny Cards app. Once you log in, you'll be able to go ahead and search for that. So just type in binary arithmetic and you'll find it. So here's your challenge at the end. Find examples of both. Okay, that might be really challenging. So find examples of both the binary and decimal arithmetic instructions. And I'm saying in the wild, as in when you're just Google searching this stuff. I already showed you one in this, and I can already see another one. So with that said, I hope these videos are helping you as much as they're helping me. I'll see you next time when we go over the logical instructions, shift and rotate instructions, and I think those are so small we'll be able to fit in this whole bit and byte instructions.